Alright, so let's take a look at example number 9. Okay, so 3 points have the coordinates a 4, 13, b 9, 3, c 10, 8. Find the equation of the line AB. Okay, so over here, okay, we can either choose to do it by the second form here. This y minus y1 over x minus x1 equals to y2 minus y1 over x2 minus x1. But my preference is always to talk about gradient and a point. So for part A, okay, we will always talk about gradient and the point. So we don't have the gradient yet, okay, but we do have a point. So we have either point A or B. Doesn't matter which one, okay, because you'll still get the answer. Okay, so now we have to find the gradient. So let's label it gradient of AB. Okay, so we can just use the formula y2 minus y1 over x2 minus x1. Usually what I will do is I'll just label this. Okay, I'm using A and B, so I'll just label this as x1, y1, x2, y2. Doesn't matter which order you choose, as long as they are paired together. So y2 minus y1, so 3 minus 13, and x2 minus x1, so 9 minus 4. All right, so if you simplify this, you will get yourself negative 2. All right, so now we have the gradient equals to negative 2. We have any point, so let's choose A. So we have y equation of AB is given by the formula y minus y1 equals to m bracket x minus x1. So we have y minus the point y1, 13, equals to negative 2 bracket x minus x1. So x1 is 4, so minus 4. So simplify my equation, I will get y minus 13 equals to negative 2x plus 8. Okay, and to get rid of the 13 on the left hand side, I will add 13 on both sides. I will have y equals to negative 2x plus 8 plus 13 will give me 21. And I'm done for part A. Now let's take a look at part B. Find the line through C and perpendicular to y minus 4x equals to 5. So we have the point. The point is given C. Now we just need to find the gradient, which is perpendicular to y minus 4x equals to 5. Again, we can always express this as y equals to mx plus c. So make y the subject first. Okay, so let's call this, let's express this as mx plus c. So y minus 4x equals to 5, y equals to 4x plus 5. So now we know that the gradient of this line is 4. So to find the gradient of line through C that is perpendicular to y equals to 4x plus 5, I just need to take negative 1 divided by the gradient of y minus 4x equals to 5, which is 4. So now I have the gradient is negative 1 over 4. I have the point C. So equation of line will be simply y minus y1 equals to m bracket x minus x1. So point C is 10 and 8. So y minus 8 equals to negative 1 over 4 x minus 10. Okay, so simplify this. I will have y minus 8 equals to negative 1 over 4x. Negative 1 over 4 plus times negative 10 will be plus 5 over 2. Okay, add 8 to both sides. I have y equals to negative 1 over 4x. So plus 5 over 2 plus 8. That will get me 21 over 2. So plus 21 over 2. And I am done. Alright, so let's take a look at part C, or rather the question with no parts. The line through C meets the line AB at point P. Calculate the coordinates of P and the ratio of AP and PB. So let's just sketch out the line. So AB is something like this. Okay. So and the line through C is also a negative gradient. Okay, so it will be something like this. Okay, again, I don't know where is C exactly. Maybe something here. Okay, they should draw the line more downward sloping, right? So let's draw something like this. Okay, again, my drawing doesn't have to be really accurate. Okay, what I do know is that it meets at point P over here. Okay, so to find the coordinates of the P is quite simple. You just have to solve simultaneous equation. So equation 1, or equation 2, and equation 1 over here. Okay, so substitute equation 1 into equation 2. So I have negative, oh sorry, this is not equation 2. The line through C is not this one, the line through C is here. Okay, so I have negative 2x plus 21 is equals to negative 1 over x plus 21 over 2. So if you simplify this, I have negative, so negative 2 plus 1 over 4, negative 7 over 4x equals to 21 over 2 minus 21, so negative 21 over 2. So simplify this, I have x equals to, so negative 21 over 2 divided by negative 7 over 4, that will get me 6. Okay, so then I need to sub x equals to 6 inside any of the equations. So let's choose equation 1. So y equals to negative 2 bracket 6 plus 21. So y equals to 9. So I have now point P is given by 6, 9. Now, to find the ratio, you realize that you can actually find the length of A, P, and PB. Okay, but it's quite tedious to actually use that method. So let's just redraw back the line. So we have A, P somewhere here, I guess, and B somewhere here. Now you realize that I can also form, based on collinearity, these two things, a similar triangle over here. Okay, so if I want to find the ratio of AP to PB, okay, the ratio of this and this will be the same as the ratio of the height of the two triangles, which will be the same as the ratio of the base of the two triangles. And you realize that I can choose to do this with y coordinates or x coordinate, but point A is at 4, point B is, as we have just found, 6, and point B will be at 9. So rather than find the length of AP and PB and do a lot more working, I can just find the horizontal distance over here, the base of the triangles, and use the ratio of similar triangles to find the ratio of AP to PB. So 4 is to 6, the length will be 2, 6 is to 9 will be 3. So you realize that now I can easily give the answer as AP to PB will give me 2 is to 3. Okay, and you can actually do this for with the the y coordinates as well. So you realize that coordinates of A is given by 13, coordinates of B is given by 9, and coordinates of B is given by 3. So 13 minus 9, this is 4 units. 9 minus 3 is 6 units. So AP to PB is still 4 is to 6, which is simplified to 2 is to 3. And if you decide to use the length of AP and PB, you will still get 2 is to 3. So we can always use similar triangles. Keep it simple. All right.